So how do you keep sterile medicines safe from a whole world of invisible threats?
It all comes down to controlling the very air around them, down to the tiniest particle.
The main enemy here is contamination. Think microbes, particles, and nasty toxins from bacteria.
To fight this, regulators demand a master plan. It's called a Contamination Control Strategy, or CCS.
And this plan covers everything. Seriously, from the building's design right down to how people are trained.
A critical piece of this whole strategy? The airlock. It's like a high-tech gateway between zones.
It's not just about doors, though. The magic is in this tiny pressure difference recommended by the WHO.
And these gateways come in two main flavors, PALs for people and MAOs for material. So how do these things actually control the air? It's pretty clever, using three key pressure designs.
You've got three main types: cascade, bubble, and sink. Each one is used for a different goal.
First up, the cascade. Think of it like a waterfall of air, always pushing contaminants out. Then there's the bubble. It uses high pressure to push air out, creating a protective, well, bubble.
And finally, the sink. It does the opposite, using low pressure to suck air in and trap stuff.
Okay, so the design is clever, but that's only half the battle. Using them involves super strict rules.
For the most critical zones, it's a one-way street. Materials go in one way and out another. The rules get even tighter here. Doors have to be interlocked, and filtered air is absolutely essential. Now, for less critical areas, the rules relax a bit. You might just have an alarm instead of interlocks. And this is why it all matters. You can't just wait and test for safety at the very end. So remember, these aren't just doors. They're a dynamic first line of defense for patient safety.
Which leaves us with a big question. What's next? How will robotics change these critical gateways?